What is up YouTube? Welcome to episode 73 of the Chaos Daily. Let's get into it. I printed 2 more wing sections. I wanted to expand on what we learned from the lattice structure that turned out really well. So I tried out 2 more lattice structures. One is just a very simple repeated vertical and diagonal pillar that's repeated through, and it's also rotated 90 degrees, so there is a repeat of the same vertical but with a diagonal that connects to the next row. And yeah, we're going to take a look at that. And also I wanted to check out how well using the slicing hollow and lattice function is. Chitubox comes with a hollow function where you can hollow the part with an internal lattice structure. It's a very basic isogrid, a 3-dimensional isogrid ladder structure. So I wanted to check out how that turned out and see how well that worked. Let's go have a look at the parts. All right, let's get this one out of the way first. This is the part that was sliced in, that was hollowed and latticed in the slicer. I had to cure it with the support material on because, as you can see, it didn't print very well. Now I know why I did this, and this is one of the issues that I have with using the lattice structure and hollow function in Chitubox. When you do that, because it's in a settings menu and it applies the hollow and the lattice in the slicing step, when you hit slice and you can't change any more features like support material or adding holes, you get this. And it's because you can't add the holes because it is a post-slice function that it causes suction or whatever, and it just sucks. Looking inside, we can see that's the kind of structure it's got. It sucks. It just sucks. Even if it printed correctly, this sucks. It's too weak. I'm sure I can find the settings that change the thickness of this lattice structure and whatnot, but it's just not worth the hassle. And I'm not paying a subscription to Lychee to do this one thing when their support structures, like doing this nice, neatly arranged support structure that gets put on the sides of this thing when I hit the auto generate. Lychee can't do this. I don't know why. They have so much issue creating nice linear progression support. Like the way their algorithm works out, way to put support material, I just can't figure it out. But this one turned out great. So this is the tressellated lattice I was telling you about. So let's get a nice close-up view of that there. There we go. You can see inside there. So this turned out really nice. This is actually quite nice and stiff. Feels really nice and lightweight, nice and strong. Again, just a little bit of that warping. Same place on the print bed. Same exact place. I've been talking to one of my patrons on our patron-only Discord, and we both came up with a similar idea simultaneously about how to figure out what this is and how to locate it on the bed using a very thin-walled grid that we would print on the bed and see what it did. So yeah, I was actually thinking of doing it, and then he mentioned it in Discord, and I was like, great minds think alike. Anyways, so let's see how much this weighs, because I'm not going to even bother weighing that other one. 28 grams, yeah, okay. So I'm seeing a pattern here. I don't know about you, but I'm seeing a pattern. So 28, 29, 28. Now I have something I found the other day that might help. Let me grab it. All right, so that's saying 29, and we're just gonna chuck 29 on there real quick. It's like 28, 29. We'll just put 29 grams. It feels lighter than the other ones, to be honest. It does feel lighter. So I have these. Now I just want to show you guys this because I tested this out. These are weights for calibrating scales. If we chuck 100 grams on here, we get 100 grams. If we chuck 50 grams on here, we get 50 grams. Here's where it gets screwy. If we chuck 20 grams on here, we get 20 grams. And if we chuck 20 grams on here, we sometimes get 19 grams. And if I add this one, 9, take that one away. Now you see that one said 20 grams before. So I think it has issues with getting accurate measurements at lower weights. So what we can do is, I will add the 100 grams and then we will reweigh it. 28, right. So I think it just has issues at the lower end of the weight spectrum. So, but I have ordered a finer resolution scale. So that is on its way, and we will reweigh everything. So let's have a look at the full set of tests that we've done so far. Okay, so we had the 0.5 millimeter shell. That was a failure. The slicing lattice that we just looked at, also a failure. You need holes basically to mitigate suction forces when it's lifting off the FEP sheet. Otherwise you get these tears. You can see it printed up to a point before it went to go pull the next layer and it couldn't. And the internal lattice is the only thing that actually stayed connected during that print process, and that's the only thing holding this together at the moment. So that's a nice aileron, but that's a failure. So yeah, I would love to be able to just make basic parts that are solid and only have the holes and stuff cut out for spars and places for servos and stuff like that, and then just chuck it into a slicer and use the slicer's hollow and lattice function. But the slicing softwares themselves need a lot more work before that is possible. So that is a failure. We're just going to bin those and never look at them again. 0.5 millimeter and slicing lattice. Right, this little pile of gorgeousness. So we learned that 2 millimeter shell is super strong, super good, but way too heavy. 1 millimeter shell, pretty good, nice and strong still. Still a bit too heavy, coming in at 44 grams. Then we got the 0.75 millimeter. This was thinner, came in at 36 gram, much lighter. It's still quite stiff, pretty good. This would work nicely with just a tiny amount of internal structure. And then from that, we went on to the straight ribs. This is what I've done in the Albatross already. We learned that my scales might be off. And we also learned that changing the thickness, the spacing and distribution of the ribs doesn't change the weight of the part at all for the change in structure that you do get. Some of these parts are stronger and weaker for pretty much the same amount of weight. You can see here, this was a much larger spacing. This one bends much easier. They just collapse. So we learned that you lose strength and you don't gain any weight savings. So that's what we learned from these straight ribs. They don't work. They work, but they don't work. They're not light enough. Next up, we have the cross-hatching. Cross-hatching was a bit stronger and a bit lighter. This is the 15 mil spacing and the 28. And this is again where we learned that there's some weird stuff going on that we haven't quite identified what this is. It could be variations in the thickness of the skin, but I don't see how that is when both of these two models in CAD were derived from the same. I made this one, and then I copied the file, and then I added extra ribs, extra cross-hatching in it. So they are literally the same skin thickness model. So it's the same shell function that creates both of these. So from the CAD side, from the model side of things, there is no change. So it must be something that occurs during printing. And I think I've worked it out, kind of. It has something to do with, I'll have to get a macro lens, and we'll make an episode on what I think it is about that, because that's a whole episode's worth of information that I need to go through. So yeah, cross-hatching, same as the ribs. This works great for FDM printing because they can print this, but they can't do all of these internal holes. That causes a lot of, every time you have to make a hole like this, the nozzle has to lift up and move to a new spot, where you prefer to get continuous printing like you get with Eclipse Sun planes. Next up, we have the ISO grids. These turned out really well. I really like this one. Why do I not have, I'll put them on the back. So that was 32 grams, that was quite heavy. Later, a few days later, this has collapsed, it's too soft. There's no structure that's stopping it from collapsing, but I think I figured out a way to make that work just by putting at the meeting of each intersection, like every other intersection, you put a little pillar that goes through, and that would work really well. So yeah, this could work better. Here we have this one. This was a tighter spacing, same thicknesses and everything, way heavier, 39, almost 40 grams, too heavy, but nice and strong, good skin support. It just collapsed because there's no support in between the top and the bottom face of the skin. And then we came to this surprise, the helical lattice. I was blown away by this. This was impressive. I was expecting this to be heavier. I was expecting something like 35, 36 grams. I'm still fine-tuning the specific gravity of the material in the CAD software. However, like I mentioned before, there is something that's going on with the printing process, as well as resin being left on the inside surfaces of the skin, just liquid resin that's not part of the exposure or whatever. It's just from the bath that stays attached to the material. It doesn't get washed off properly or something. Those sort of things, it will give me variations in weight by a good 3 or 4% if my estimations are correct. But yeah, this turned out really well, nice and strong, good support, bit heavy though. And then like we just did, we tested the tesselated lattice. This is the way to go, I think. This is the winner. The lattice structure is very easy to model. It's very easy to implement. It will work with pretty much any design that I choose to use. It gives good support all around the skin. It's nice and strong. It's actually stronger than some of the other like the cross hatching and that. The same kind of weight. We've kind of hit our hard limit of about between 25 and 28 grams for like these minimal internal structure lattices, and as well as ribs and cross hatching. So I'm going to keep working on this. I'm going to try a couple other variations of this and see if we can get it even better. But I want to wait until my new scales arrive so that I can get more accurate feedback on how much weight I'm actually saving versus how much strength I'm gaining or losing. But yeah, this is definitely the way to go. We have our winner. We will use a tressellated lattice system. It works really nice. It's really simple. And I didn't expect it to be this stiff and this strong. Like, I really wasn't. These are only 1 millimeter lattices in here. So for the weight savings we get and the strength and distribution we get, I mean, I'm putting quite a bit of force to try and bend that, and it's staying quite distributed. Like, it's not kinking at any one point. It is transferring the forces evenly across the whole surface. So there's great force transfer through this material. So this is the way to go, and we're going to keep going with that. So there you go. That concludes our testing phase of going through and finding the optimal support structure that will work for going forward with other projects. I'm now going to go through and redesign the wings for the Albatross, wherever they are. I've hidden them, they're up there. So I'm going to redesign those wings for the Albatross, rip out everything, start again from scratch. I probably want to redo the ailerons again, just because when it comes to that support structure in the lattice, it's not going to work for those ailerons. Those ailerons are going to turn out heavy however I do them. Yeah, I'm going to go and do that and get that ready to go, and so we can start printing. I have a batch mixed up of the white and blue. These are, I don't know if you noticed, but I have these. I poured out a little bit of resin from each of the bottles and put it in the curing chamber on my silicone mat. It's just so I can easily identify what bottle is underneath it, because it's a little hard to read the writing sometimes. But yeah, so that's nice and neat, and it gives you a good indication of the strength and quality. The tenacious. I want you to see this. This is a Siraya Tech's tenacious resin. This is incredible, and it slowly goes back. It's very much like a gummy sort of feel rather than like a rubbery feel. It's not quite like a silicone. It's very hard to describe. It's almost like it's half cured, but it does slowly go back to its original form. So I've got some really like interesting ideas of what to do with this in the future. Maybe 3D printing the wheels for like the Draco out of this material, and actually see if I can make it airtight and make air-filled tires, like those big Alaskan bush tires, because they're going to be quite large. That should be pretty fun. That'll be a lot of fun to do. So we'll have a look at doing that in the future. I've also had some other ideas for using that tenacious resin for when I basically 3D print a wing and the ailerons, and instead of using a hinge, I lay the two out on a silicone mat and pour some of that tenacious in the seam, and then cure it with a UV light, and then I have a rubberized flex hinge. So that's another really cool application that I'm going to try out on a couple of different applications. Also compliant mechanisms, that stuff is going to be great. I'm going to start playing with all kinds of compliant mechanisms. I really can't wait. It's super exciting. So yeah, this episode's gone a bit long today. Make sure you hit the like button, make sure you subscribe, and go check out my other channel if you're new to the channel. If you're new to the channel, and I know you are, there's a couple of you, welcome. My name's Chaos, and as always, expect the unexpected, and I will see you guys later.
And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.